functions. I'm going to keep this video super short because I think a lot of what we're covering here is best covered together in class. But let's start with the definition of analyze. So to analyze is to examine carefully in detail. Okay, this is how you assess what you're looking at in any kind of graph or function. So the one example that we are going to go over together is this board length example. So as you guys can tell, this looks a little different than our typical XY graph that we've been studying so far. So this top component here that says board length, this is just the title. Okay. This bottom line here, which is represented by time, is our x-axis. And this vertical line here represents our y-axis. So the reason why our graph looks like this is because it is a first quadrant graph, meaning that both our length of the board and the time has to be positive. So we're really only assessing this first quadrant. So let's go down and look at our questions here. What are the variables in the graph? So our variables, we have our x-axis, which represents our time, and we have our y-axis, which represents our length. Okay. Describe how, sorry, you guys can't see this yet. Describe how the variables are related at various points. So let's look at our graph here. So as time continues, it appears that the length of our board keeps decreasing, right? So for like a minute, our board's pretty long. And then it decreases. And then a minute later, it decreases again. A minute later, decreases again. And then it stays the same. So I would say that the length of the board is getting shorter over time. Okay. The next question here is how many cuts are being made? So let's go up to our graph. So we made a cut at, say, minute 1, made a cut at minute 2, made a cut at minute 3, and then it all stayed the same. So I could infer from this graph that we made 3 total cuts. Okay, is there a piece of board left at the end of the time shown? Okay, let's go back up here. So at the end of the time shown, it ends right there. So at this point where it ends, it does appear that we still have some length remaining because the length of our board hasn't hit the x-axis, it hasn't hit 0. So I would say that yes, because the length of, oops, length of the board doesn't hit 0. Okay, we still have some length left over. So for the rest of this lesson here, example 2, let's do this together in class. Please copy down this graph before you get to class. It'll save us a ton of time. Okay, and we can just talk about the analyzation process. Okay, this application and everything else we're going to do together in class. Once again, please copy this down before you get to class so we can just go ahead and talk about it. Not a huge deal either way. And then we're going to do all of these things together in class. Okay, I know this was a super short video, but thank you guys for watching.